Okay, here we are again. So this is where we were. We were starting a new model, well, it's a new version of the model. And so far it's been infrastructure. We've solved one version of the model. We didn't learn anything particularly exciting and new other than there's this distinction between adaptive expectations and rational expectations that is the difference between the way it used to be done in the 50s, 60s, and the way it's done ever since mid-70s till now. All of macroeconomics is using rational expectations, except for occasionally not, but really rational expectation is the way to go, partly because it's not having people systematically tricked, right? With adaptive expectations, people are going to be systematically tricked, not just making a mistake, but tricked the same way over and over and over again, which doesn't seem like an ideal way to set up a model, an ideal way to have your predictions of how the world works. But also because with rational expectations, it's very easy for us to just assume the expectations in such a way that, okay, I'm going to change this so we don't get feedback. Just bear with me here. It's over here. I'm not a big fan of the feedback. Okay, maybe this is better. Let's hope for the best. So it's very easy to set up the expectations in a way to get what you want because you're just sort of assuming this is the way that people behave, this is the way people form their expectations. Whereas actually we think people understand a bit about how the world works. And if we think that the model is our way of representing how the world works, people should know that. Right? Now it is a bit extreme. It implies more cleverness on people's behalf than most of us are really capable of. But this is the way we've gone, right? So it's an extreme version, but it's capturing something real. And most importantly for us, it's tying the hands of the theorists to say, look, we're not going to be able to base our predictions on systematically tricking people over and over and over again. We can maybe trick them once, maybe trick them twice, but it can't be a systematic thing. That policy is driven by our ability to trick people. Okay, so we had that. And we found that in that model, the initial model that we had, that we could use policy to affect output. Right? We use monetary policy to affect output. And that was happening because people had these short-term contracts. And when the contract was made, they only had information at time t minus 1, but the things that developed in time t mattered. And we were able to react to those things instantly. So the policymaker was able to react to shocks that individuals were not because they had these short-term contracts. Okay? Now, this is nice to know, but I don't think it's shocking or weird, or we haven't learned a lot other than, okay, you can do some math to do that, which is lovely and gorgeous and all that, but it's, if the policymaker knows things that individuals don't, the policymaker can affect output is not a big shock to anyone. So we're coming up with this version of the model. And this version of the model is the same as we had before. Okay, let's move this out of the way as well. The same as we had before. We've got our output is depending on price prediction errors, right? Which is, again, that people are setting their wages based on their information at time t minus 1. And then the prices that happen affect the real wage, right? So here, this PT minus PT minus TPT given t minus 1 ends up being the real wage. Okay? The inverse of the real wage, so we have a negative effect. And then we have how monetary policy works, how supply and demand for money works. So this is the quantity theory of money. And importantly, we have this shock this velocity is just an IID shock. So it doesn't hang around. You get a shock today, tells you nothing about the shock tomorrow. Okay? And the thing we're changing from last time is this. Right? Before, we had our monetary policy depended on the shock at time t. Now we're having it depend on the shock at time t minus 1. So we're not able to instantly react to news. First of all, in real life, people don't know the news for a while. Right? Something happens in the economy. It takes us a while to gather the statistics, and so you don't know it. And secondly, monetary policy, we pretend like it's instantaneous, but it's not necessarily instantaneous, right? We have that whole money multiplier. Right? When you put money into the economy, what happens? You put the money into the economy, people put it in the bank loans it out, creating more money. The people that borrowed the money put it in the bank loans it out, and there's this whole multiple rounds of lending, saving and lending. That clearly in real life takes time, right? And so we can say, oh, the money multiplier is this, but in fact, it's going to take some time to take effect. So this idea that your monetary policy is instantaneously effective is a bit problematic as well. Okay. Now, we are going to see some senses in which you can think of it as being instantaneously effective. In fact, we are going to see an example in this model where it is the promise of taking policy action tomorrow that gets things to affect things. But at the moment, we don't have any of that. And so we're really just thinking, by the time we see the nature of the economy, the state of the economy, and by the time we see that and able to get our policy to affect anything in the economy, it's going to take us a period, right? So we can only react to time t-1 shocks. Okay? That's our story. And I think that's a more realistic story. Obviously, we don't have everything that we would want for a realistic model, but this is moving in the direction of realism to do this, right? Okay. So first of all, we want to solve this. We want to learn from this. And secondly, we want to use a new method of solving. And the new method is going to be the guess and verify method. Okay. Okay. Which sounds really scary, because what if you guess wrong, then what's going to happen to you? It turns out these guesses are really easy to make. It's not going to be a problem for us. It won't be a problem for you after you do, if you see 2 or 3 of them, it'll be totally obvious what to guess. But also, if you guess wrong, the verification process is going to tell you that you're wrong, and it's going to tell you in which way you're wrong. So, okay. So what we do here is we have these equations which represent the world and how the world works. And in particular, the thing that bothers us are these price prediction errors, right? And we got those price prediction errors. So we need to know how prices behave to figure out what people expect of prices to be. Right? In order to figure out people's expectations of prices, we need to know how prices work. And so what we want to do is we want to take all the information of this model and put it into something that just gives us how prices work in this world. Okay? And so in particular, we want to eliminate y, because we're not interested at this first stage about how output is determined. We're interested in how prices are determined. So we're going to take 6, plug it into 7, and we get this star. This equation here, which is how prices work in this world. Okay? But of course, it still depends on expectations of prices. And so now, once we have that, which is what we did last time, now we want to say, this is how prices work in this world. Now we want to find some kind of reduced form for prices. That is, something that doesn't depend on expectations. We want to find out how prices depend on the parameters, the shocks, the things going on in this world, but not on us, what we believe about the future. We want to eliminate that and just say how prices depend on the exogenous stuff in this model. So in that case, it's particularly going to be, well, our theta is going to be important, our gamma is going to be important, but also these shocks are going to be important, et minus 1. And so I'm going to make a guess about how the price process works, and I'm going to guess this. I'm going to say PT depends on today's shock, and it depends on yesterday's shock, with some parameters, or functions of parameters multiplying those. Why did I pick that? Well, I look at my price process, and I say, okay, there's this PT given t minus 1, which is a mess. But other than that, let's ignore that for a minute. We got 2 things that show up. We have today's shock and yesterday's shock. These things both show up. So probably prices are going to depend on those. Okay, maybe not, because there's this expectation term, and maybe that eliminates it. But if I had to guess, which I do, because it's the guess and verify method, if I had to guess, then I would guess, well, the things that are showing up in this star equation, the equation that represents what's really going on in the economy, they're probably going to show up in the reduced form too, right? This is not like rocket surgery or anything. If it's there, it should be here, right? It's just that easy. You can't see. Yeah, there, it should be there. Right? You need a pointy stick and point things at that. Right? Okay, so it should be there, so that's what I'm going to guess. Okay, that's my guess, that it depends on all the things I show up in the real process, which I'm calling star. All of those things should show up in my reduced form process, but somehow eliminating this bit. Okay, somehow. Okay, so that's what I've done. Now that's fine, I can guess whatever I want, right? It's a guess. I could guess it depends on, anything. It doesn't have to even depend on things. I can guess whatever I like. It could be the square of the shocks. It could be the cube of the shocks. It could be one shock divided by the other. I could guess whatever the heck I like, right? But we're looking for rational expectations. So we want this expectations to result in a process that's consistent with our guess. So the important step here is I made my guess. Now I have to verify that my guess is consistent with the model. And in particular, consistent with star. So now I need to verify this thing. Okay, so what I'm going to do is I'm going to take this guess and pretend like it's true. Okay? We know star is true. It came from the model. Star is the real thing. But I'm going to take this guess. I'm going to pretend like it's true. And I'm going to plug it back into star. And then I'm going to see if the resulting equation looks anything like my guess. And if it does look like my guess, great, it was a nice guess. If it doesn't look like my guess, it was a bad guess. It's not consistent with the model. Okay? Okay, so I've got, let's write it down, PT equals ET plus gamma ET minus 1 minus theta PT minus PT given T minus 1. That's my star equation. That's the reality in this model. And then I have my guess, which is PT is equal to R1 ET plus R2 ET minus 1. And these R's are things that I don't know yet. There's some constant multiplying the shocks. I don't know what they look like yet, but I'm going to see if there's any R's that are consistent with my guess. Okay, so clearly the trouble in star is this bit here. Right? So what I really want to find is if my guess is correct, what is this PT minus PT given T minus 1? What the heck is that? Okay? And PT, if my guess is correct, PT is just this. So what I need to find is this expectation term. If the world behaves like my guess, what do people expect prices to be tomorrow, right? So I have PT is equal to R1 ET plus R2 ET minus 1. I just repeated the guess. But now I'm going to take expectations of this one period later. Because if the guess is correct, this is how the price process is going to work in the end. Okay? If it's correct, this is how it works. And so when people are making their prediction of the future, they're going to take that into account. So I'm going to take, on the left-hand side, they're guessing what prices are one period earlier, at T minus 1. They're making their best estimate of what prices are. And that has to be equal to the expectation of the right-hand side. And so that's their best estimation of what the shock is going to be in time t, one period later, in time t minus 1. They're thinking ahead. What is the shock going to be one period later? And they're thinking ahead, what is the time t minus 1 shock going to be one period later? Well, it's still going to be itself, right? So what we know is that this is mean 0. So the expectation of tomorrow's shock is 0. I know that sometimes it's going to be high and sometimes it's going to be low, but on average, it's going to be 0. Right? That was an assumption that we had on epsilon. Okay? And this is already known. Right? Because they're saying, okay, today t-1 shock is going to be hanging around tomorrow in this price process, but I already know what that is because I'm looking at time t-1, what do I think the et-1 is going to be? That's already known information. Right? So there's no estimation involved. I already can just look out in the world and see what the shock is. And so this pt given t-1 is just equal to r2 et-1, if the guess is correct. Now, which it might be, it might not be. Obviously, I've done this before, and if things aren't like last time, it'll be correct, but you know, we'll see, we'll see. It's exciting times to be alive. Okay, so we're looking for this price prediction error. So what we really want to know is what pt minus pt given t-1 is. So pt minus pt given t-1, that's our price prediction error. That equals pt. If the guess is correct, pt is just this. So that's r1 et plus r2 et-1 minus pt given t-1, which we just found, is r2 et-1 pt, I'm sure you can still, pt minus pt given t-1 is equal to, this cancels with that, and we just get r1 et. If the guess is correct. Right? That's our price prediction error. And that shouldn't be too shocking, right? Because if you look how prices behave, prices depend on things we don't yet know and things we already know. And so if I'm going to make a mistake, it's going to be because of the things that I don't know yet, right? I'm not going to make a mistake based on the things I already know because I know them. I'm going to make a mistake because something comes up that I didn't yet know, and that's the shock in period t. Right? That's all that's saying. Okay. So now I plug that back into star. For the verification stage. So pt is equal to et plus gamma et-1 minus theta times r1 et. Right? This is the price prediction error. Okay. Go on to page 7. Can you see that? Yes, you can. Okay. So we get, simplifying that, I get pt is equal to et plus gamma minus theta r1. Oh, sorry. Let me do that again. pt is equal to 1 minus theta r1 et, combining all the et terms, plus gamma et-1. Right? And now I'm wondering, does it look like my guess? I'm sorry, does it look like my guess? And my guess was pt is equal to r1 et plus r2 et-1. Okay? Do they look the same? So I've said, suppose the guess is correct, plug it into the real equation, taking all the expectation terms and all that. plug it into the real equation, and then I see if the resulting thing looks like the guess that I had in the first place. Okay. And if it does, grand, my guess was fine. And if it doesn't, I guessed wrong. I got to start again. Okay. Now, at first glance, this looks really encouraging, right? Because the guess has something multiplied by ET, something multiplied by ET minus 1, and I got something multiplied by ET plus something multiplied by ET minus 1. Okay, so that's very encouraging. But it is possible that there's no R1 and R2 that make these the same, because these have to be the same. They can't just be generally, vaguely looking the same, but they have to actually be the same. So I need R1 equal to this. And R2 equal to gamma, right there. Okay. R2 equal to gamma is clearly possible. R2 equal to gamma, that's good to go. Right. But R1 equal to this, what does that mean? That means put all the R1 terms on the left. I get theta plus 1, R1. Theta from here, 1 from there is equal to 1. So R1 has to equal 1 over 1 plus theta. R2 equals gamma. And so now the result as our guess. So yes, we verified it. We can get a form of this thing that looks exactly the same as our guess. If we pick our parameters equal to these things, then our actual process and our guess are consistent with each other. Right? We want them both to be true at the same time. And so what we get is we get our actual process, PT, is equal to R1 times ET. R1 is 1 over 1 plus theta ET, plus R2 times ET minus 1. R2 is gamma. Let's see. Things I want to say. Yeah. All right, so this makes the two consistent. So this is a solution to our set of equations, and this is an equilibrium price process. Now, one thing we lose in the guess and verify method is that we can't guarantee that this is the only solution to our thing. Now, typically, what solutions look like to a price process, not in this model so far, but what they look like, you would solve it as a difference equation, which is a whole realm of math that engineers are fond of, but economists as well. Right? Because our price process, if we go back, price process has something to do with t, but also something to do with stuff that came up at t minus 1. So we would solve it as a difference in prices thing. And what you often get in these is there's a fundamental thing going on, and there's a thing that just depends on time. Right? Because if you're trying to predict prices, the prices are going to depend on some fundamental stuff. But a lot of times prices can go up just because you think they're going to go up. So for example, we might have stock prices, for instance, right? And you're wondering about what the fundamental value of the company is. But also, if you think the stock price is going to go up, you're going to buy, right? And that will itself cause the stock price to go up. And so you can get things that you can get in these expectations-driven models. You can get situations where prices depend on the fundamental stuff, but they also can have have a portion that depends just on your expectations of prices going up, or just on your expectations of prices going down. And these are often called speculative bubbles. Like you can have the price just going up, 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 until it consumes all money in the world. So clearly that can't go on forever. Or you can just go have the price going down, down, down because the stock is a company, it's perfectly good, it's producing stuff, it's making a profit, but everyone thinks the price is going to go down, so we all sell, which makes the price go down, and pretty soon the price is next to zero, and then some vulture fund comes in and picks it up on pennies for the dollar. So clearly that's not stable either, but you can have these sort of things. And what we miss in the guess and verify method is we miss seeing those things, because our guess that we typically come up with is based just on the fundamentals of the economy. Right? When we were making our guess, we were looking at this and we say, okay, the fundamentals of the economy depend on ET and ET minus 1. Let's stick those things into our guess. And we didn't leave any room for prices just to go up because we think prices will go up. Something that just depends on time and not on the fundamentals. We didn't leave any room for that. We don't know whether that exists or not because we did a guess and verify method. Right? It makes things simple. It means that I can teach this in a second-year class, but it also means that we're leaving out stuff about bubbles. Now, in fairness, a lot of macroeconomics leaves out the stuff about bubbles anyway, because when they talk about speculative bubbles, they want a model designed specifically to deal with speculative bubbles, to take in the stuff that matters for that. And so they tend to have a speculative bubbles literature and a macroeconomics that depends on fundamentals of the economy, the shocks, literature, and there's not a whole lot of overlap between the two. So there's a whole branch of macroeconomics that's going to ignore those sorts of speculative bubbles like we're doing here. But you should be aware that they're there, and if we wanted to really solve this model for all the possible solutions, we would need to use difference equations and get into that. Okay? Whole mathematical infrastructure that's involved in that. Not particularly hard, but a lot to learn. Right? Nevertheless, we're in a great spirit of modern macroeconomics by ignoring speculative bubbles, and the guess and verify method will do that for us. Now, of course, you could guess the speculative bubbles in there as well, but you'd have to know what they look like already, so you'd have to have gone through that whole thing, and you would never be sure that you got them all. Right? Because we're just guessing. Say, suppose there's an equilibrium that looks like this. Yes, there is. But there could, of course, be equilibria that look like other things, which we didn't guess. But this is an equilibrium. And for this class, like most of macroeconomics, this is good enough. Okay? But we're leaving stuff out. Be aware we're leaving stuff out. OK. So now we've got our price process. Now we've got our price process. So we got price at time t is equal to 1 over 1 plus theta et plus gamma et minus 1. But we're not actually interested in prices so much. Right? We could be interested in prices, but usually we're more interested in output. Right? So we're not really wondering, can monetary policy affect prices? Of course it can. You print enough money, prices are going to go up. It's a given. Right? But we're interested in, can monetary policy affect output? So we want to convert this into output. And if we go way back to the mists of time, we had equation 6, which was yt minus y bar is equal to theta pt minus pt given t minus 1. All right. And so, yeah, we have price prediction errors and how they affect output. So lovely. Now we know how prices work. We know what price prediction errors look like. And in fact, we found earlier that pt minus pt given t minus 1 was equal to, what was it equal to? Let me get it right. Always happy if you get it right. Equals R1 ET, right? Because you never made mistakes because of ET minus 1, because that was already known when you were forming your expectations. You only make mistakes based on new information. And so that, we found out what R1 was. And so that's 1 over 1 plus theta ET. And so 6 yt minus y bar is equal to theta times this theta ET. Okay. And that's how output behaves in the economy. Okay, what do we get out of that? What do we learn out of that? Well, the first thing we learn is that we got no gamma. Right? Remember, gamma was our policy variable. We had MT equals, if I can get this right, always nice, equals gamma ET minus 1. That was how we set our money supply. And here, the way we set our money supply doesn't affect output at all. Right? Every time we see a shock, we're increasing the money supply. Or every time we're seeing a shock, we're decreasing the money supply. It doesn't matter for output. It does matter for prices. Right? Here, we still see that. Here, prices are affected by gamma. If I'm going to react to yesterday's shock and increase the money supply a lot, so gamma is positive, then prices are going to go up with a positive shock, and they're going to go down with a negative shock. Right? But it's not going to affect output, because output comes from people screwing up their price prediction. Right? They're trying to set their wages. If they set their wages in line with the prices they see, nothing real has changed in the economy. Right? And so since they know how we're going to react with our monetary policy, they know that next period we're going to react to ET minus 1, multiply it by gamma, change our money supply by that much. They know what we're going to do because they know the shock already. Then when they're forming their expectations, they can just say, yeah, whenever there's a shock, he increases, today's shock, he's going to increase the money supply, prices were going to be high. So I say, well, prices are going to be high. We set high wages, the real wages are normal, and we get normal level of output. Okay? So we don't make mistakes based on this because it is already known at the time we're setting our contracts. So you can do whatever you want with monetary policy, at least in this linear version, but in fact anything you want with monetary policy. It won't make any difference at all in this model because people have all the information to perfectly predict what the monetary policy is going to be. Okay, so if you're going to set it high, well, they take that into account. If you're going to set it low, they take that into account. So there's no news there. There's no way that you were surprising them. And which is what the big difference is from the previous version, right? The previous version, this depended on ET. And monetary policy did matter. Gamma did show up in this equation, right? Because there, people didn't know what the shock was going to be. Therefore, they didn't know what the monetary policy was going to be. They didn't know whether money supply was going to be high or low. And so that was a surprise to them, and therefore we could affect output with them. But here, the central bank has all the same information as normal people do, and so when they're setting their wages, central bank already knows that stuff. The people already know that stuff when they're setting their wages. They know what the monetary policy is going to be, so they don't make price prediction errors because of it, and it is price prediction errors that drive output changes. Okay? People with me here? Questions about this? All right, this sounds like no big deal, but it was like a huge thing in macroeconomics in the 70s. We got like several Nobel Prize given for this thing because a lot of the things that you would normally, that they had up till then talked about, okay, monetary policy, we can use it this way, that way. Well, no, once you start realizing that people are going to try to predict your policy, if they have the same information you do, they're going to be able to predict it. Right? If they know how you're behaving, if they know the information that you're using to set your policy, they're going to be able to predict your policy and they'll build it into their wages. And so that policy will be totally ineffective. Yeah?
How does this model work with the minimum wage?
With minimum wage? I haven't thought about that. We can speculate. So the question is, how would this work with the minimum wage? So you can imagine, clearly, if you're increasing the money supply, that would be no problem, right? Because minimum wage lets you have the highest wage you want. But if you had a negative shock and prices were going to go down, but you couldn't set a wage below a certain amount, yeah, then it would start to matter, right? Because you'd say, okay, they're going to reduce the money supply. We're going to have a shock. They're going to change the money supply. We're going to be below the minimum wage. But we can't do that, and so then you're off your target wage, you're off your normal level of output, and yeah, it would have an effect. So if you put minimum wages in here, downturns, unless you were, Unless you reacted negatively to the shock to make sure that prices didn't go down, but reductions in price would cause real output changes, but only in a negative way, right? So if we had this model and we had a minimum wage, right, what would happen is you'd be going along, it would be just like this, just like this, just like this, and then at some point there's going to be a shock that's going to make it so that it's going to reduce prices, right? And if your monetary policy is to keep the prices there or reduce prices even further, and there's a minimum wage, then they can't lower the wage enough to take that into account, right? And so that's going to cause a recession, right? Because your wage is too high, you find it expensive to hire workers, and so you would get a minimum wage would only cause unemployment under some circumstances. Now you could avoid this unemployment by simply increasing the money supply in those circumstances, and then people would take that into account, right? So it's not a great model of showing that minimum wage can cause unemployment, but it would be a feature of the model, right? It wouldn't be a great model because it says that the monetary policy should take action to make sure that doesn't happen. Nice question, I like that.
The best solution could be the central planning economy.
The what?
Best solution for this model would be central planning economy.
Why is that?
Go to central planning. You know, we plan everything. What money and wages and everything. Like back to the communism. Not really, because assuming that you can't react, like it all comes down to the same thing, like if you wanted a planned economy in this. And the big question in that is, what can you react to? When you're planning, can you plan instantly after the shocks are realized, in which case you could smooth everything out? But if you're planning your economy based on T-1 shocks, if the plan takes a while to happen, then the shocks are still going to have output, and people will take into their expectations everything that is in your planning as well, to the extent that they have ability to set wages, obviously, right? Okay. Okay. I put that down not because it's news to you, I just said that, but because when you're looking at the notes later, you're going to want to see that, right? Okay. Okay, so let's make it a bit more realistic. I'm going for realism. Two things I want out of the realism is that we're going to see this at work in a more realistic way. To show you how you can add realism, and also to give you more experience with the guess and verify method. Okay, so I'm going to have a different model. I'm going to have a different 6. 6 prime is going to be yt minus y bar is equal to 1/2 theta pt minus pt given t minus 1 plus 1/2 theta pt minus pt given t minus 2. Okay. So what's the story here? I can do that. I can do whatever I want. It's my equation, my life, and you just have to live with it. But why? Why would you do such a thing? Like, be a decent person. Don't do that. Well, the story here, if I can get this to lock on me, yes. The story here is that, look, these are short-term contracts. Right? And so suppose these are year-long contracts. You go into to your employer, and barring some unforeseen weirdness, you're going to keep that wage for an entire year, and then you're going to renegotiate, right? But suppose that not everyone renegotiates their wage at exactly the same time. So half the people are doing it at the beginning of the first quarter of the year, and half the people are doing it at the beginning of the third quarter of the year. So they're staggered, right? Half the people doing it at one time. And so when I get my new contract, it doesn't mean that you got your new contract. And when you get your new contract, I might still be locked into my contract. So here we're thinking about a period being 6 months, So there's some people that negotiated their wages a whole year ago, and there's some people that negotiated their wages 6 months ago. The people that were negotiating their wages a year ago, that's 2 periods ago, they were trying to guess what today's prices were going to be based on information 2 periods ago. Right? So they had T-2 information to try to predict today's prices. Okay? Whereas the people that only renegotiated their wages 6 months ago, they have T-1 information to guess today's prices. So we're thinking in this term that a wage contract is not just a wage for the whole time, but it's saying I'm going to get paid 10 euros an hour now. In 6 months, that will be 11 euros. And in 12 months, it'll be 15 euros, right? So it's like the salary negotiations the trade unions do here, like the public sector salary negotiations. They give us a whole schedule about how we're going to get wage increments over the next 5 years, right? So we have that kind of contract. So when you're guessing it 2 periods ago, you're saying, let's have a particular wage now, a particular wage in time T-1, and a particular wage at time T. Well, not that time. So we have price prediction errors for 2 periods for these guys, but only 1 period for these guys. People with me here? The story? Okay. Now, when we were doing the Phillips curve model, we kind of talked loosely about this kind of thing. We talked about, or maybe it was last year when we were doing the aggregate supply, aggregate demand. Right? We talked about, well, okay, you can have this rational expectations equilibrium. So suppose you have really high inflation and you put someone into the central bank that's really against inflation, right? And a couple of things could happen. One, we could not believe that they changed the guy, and so then we have recessions for a while. But another thing that could happen is we say, we got rational expectations. We know we got this new guy. We know he really hates inflation, so inflation could come down right away, okay? That was our initial pass. But another thing we could think is, well, maybe some people are changing their wages now, but other people have to wait till their contract comes up. And it's going to take a while for them to do their wage changes. And so now, even though it's my turn to renegotiate my wages, and I know that we have this tough guy in office, I might not bring my expectations all the way down because there's these other guys that are still locked into contracts. And so the fact that these other guys are locked into contracts keeps me from lowering my wages too much either, and so it takes longer for wages to come down. Okay? That was a story we told, but it was just a story. It was just me, blowing smoke. Here's a fun thing I can pretend is in the model, but when it's not, right? But it's a nice way to think about it in that model, and it's useful to think about it in that model. But it was just kind of loosey-goosey, me making up stories, which is fine as far as it goes. But yeah, it is what it is. It's just me making up stories. So here, now we got like the math and stuff, and we can see whether our stories are consistent with our thing. We don't have the neat, tidy graph, which was lovely and fun to play with, but we do know whether things are consistent with our assumptions, right? And we can work out exactly what's consistent with our assumptions, exactly what's not, and exactly what assumptions we need. So here in math, I'm trying to tell that story, that it's a little bit harder. We don't have the indifference curves. We don't have the policymaker in the same way. But it's getting at that story that, look, some people are going to be locked into their wages from 2 periods ago. Okay, so we've got that. We've got 7 will be the same as before, which will be mt minus pt equals yt minus y bar minus vt. That's the same as before. But we're going to have one important new thing as well, and that's to make our shocks more realistic. And so far our shocks have been completely idiosyncratic, right? Knowing something about what's going on today told me nothing about shocks later on in the future. And that's not how reality works
either, right? When things go bad, they tend to go bad for a while. And when things go good, they tend to go good for a while. And it would be nice to incorporate that in, like whatever this shock is. Like suppose it's OPEC raises oil prices and that's our shock. Well, that's great, but they don't just do it for a day, right? It takes them a while to like start fighting with each other. And so that shock sort of stays around for a while. Or, you know, suppose there is war in Ukraine. Ridiculous, I know, but suppose it happened. Suppose it happened and that affected natural gas supplies and all of that. It's going to take a while to work itself out, and so these shocks are going to stay around, right? And so I want to specify something where shocks aren't just totally idiosyncratic, but they actually stay around. Okay? So the way I'm going to do that is, if I have my notes here, I'm going to say Vt is equal to rho Vt minus 1 plus epsilon t. This is a Greek letter, and we're going to assume that it's between 0 and 1. So it is the portion of shocks that stay around. And then Et is still, Et is IID means 0. And the nice thing about this is that all of our epsilon t's are going to behave in the same way that we know and love, but velocity, which is what matters in the model, is going to hang around, right? We could suppose, for instance, suppose V0 equals 0. And this is not likely to happen, but just suppose, just to sort of see how this works. And then E1 equals 1, and then E2 equals E3 equals E4, all of them equal to 0. So the idea is we're going along, everything's stable, we get one shock, and then everything's stable again. Okay? Not likely to happen in reality, but this is just to give you an idea how this process works, right? And so then we can figure out what Vt is equal to, right? V0 is 0. V1 is just rho times 0 plus the shock, so that equals 1. V2 is equal to rho times 1, rho times Vt minus 1, plus 0 equals rho. V3 is equal to rho times V2, which is rho itself, plus 0 for the shock. That equals rho squared. V4 is equal to rho times Vt minus 1. We can still see Vt minus 1. Vt minus 1 is rho squared, plus the new shock, which is 0, equals rho cubed, and so on. So if we graphed this, time Vt, at time 0, we have nothing. At time 1, we've got 1. And then 1, 2, 3, 4, 5, and so on. It's going to decrease. Let's say it goes by half. Let's say rho is 1/2. So it's going to be half as much as it was before, and then half again as much, and then half again as much, and then half again as much, half again as much. And so the whole thing is going to look just decaying towards 0, right? So this shock is sticking around. I can specify it with my epsilons that are still IID means 0, so I can work with them. But you can see velocity itself is going to stick around. If something happens in time 1, a bit of that's going to be left over in time 5, right? So even way off in the future, things that happen today are still going to matter. Thus, exogenously, forget about like endogenously because of central bank behavior or people behavior, but just mechanically, the shock is going to hang around. Okay, I got to let you go, and we'll solve this next time.